So today we are going to start about OpenGL lights, okay? Lighting is very important in computer graphics. You can change the light to change many things, and we will see that how by changing the light, you can change the material, or you can change the color of the scene, and how you control lights by their color, by their position, etc. So we are going to study it today, inshallah. So first, we need to understand what is a light source. Okay, if you remember in the last lecture, I told you about the position of eye when you look at things in OpenGL, how you define things and draw the things on the screen in OpenGL. So that was the position of the eye. Similarly, we have position of the light, okay? So here in this example, for example, you have a light, okay? The light can be, here like this is sun, or the light can be an artificial light, okay? You can define that. And this light will have its rays on the object, and on that side of the object, where there is light, you will see something like this. Okay, so that is the light example. Now we see that light can be two possibilities. It can have at some specific position. Okay, so we can have a position, let's say on which side of the object, or it can be known as the sun, Shams, which is considered as a light source at an infinite position, which means that the position will be very far from the object where it is. So if you design games, let's say, or in general some graphics applications in which you define the sun, so it means the light will be available from every side, okay? It can be available anywhere. It's not just like light bulb. Here in the room, I have light bulb, but if I go out, for example, in the corridor, in the mamar, so the light will be different, okay? That's the positional light. But when we talk about sun, so sun can be like available everywhere. That's what we know in general. So light source has, a color, and we call it the diffuse color. Now remember these things, okay? Because I'm going to ask you this in the exam or in the quiz, etc. So first is diffuse color, which is the color of the light. Because lights can be different color. It can be white light, it can be yellow light, and we see the blue, green, right? or any type of color. So that is known as the diffuse color. So in OpenGL, we can define up to eight light sources, which means that in a scene, you can place the light sources at different positions, up to 8, and we call it as the GL light 0, GL light 1, up to GL light 7. So these are the numbers for each different type of light, okay? For each light, we can have different color, and we can have different position of these light sources. So when you want to use light in our OpenGL program, first, we need to enable that. Just like if you remember when we wanted to use 3D, okay, then we need to enable the GL depth test, okay? Here we will enable the GL lighting. So it means that I want to use light. Then after enabling the light, you will enable the light number which you want. Okay, so let's say we start with light 0. It can be any number, okay, but we start with one number, light 0, and we will then set that light, its position, its color, etc. Okay, so remember, first we need to enable the lighting, and then we need to enable the light that we want to use. Here in this example, we are using only one light. Next, we know that now there are three things about light. The first thing we discussed is diffuse light, which is the color of the light, okay, which is directly falling on the object. So from the light bulb, a light is falling on the object. It will have a color, and this color will change how the object will look like. Okay, we will see the example, but remember the definition that diffuse light is the light which is thrown directly from the light source onto the object. Then the second type of light is ambient light, okay, which is the light that is reflected many times such that its source is unknown. Then it falls on the object. So normally we know about the reflection, okay, the axis of the light. So light may reflect many times, depending upon the room, depending upon the walls, depending upon the properties of the environment. So this light is not just going directly onto one surface, but it may reflect and then it may fall onto another surface. Okay, so this light, this type of light, which is not direct, but that may be because of reflection, is known as the ambient light. Okay, then the third one is the specular light. This is the light which shows the shininess of the light source. Okay, how much shine is there? I don't know shine in Arabic, but shine means the property of the object. Like, for example, you see that plastic may be shiny, for example. Okay, so plastic, different types of plastic, they may give different types of shines. Similarly, different types of paint on the wall, they may give different types of shine. Some colors, they don't have shine, or some material, they don't have shines. Okay, so shininess of the material is actually the property of the material that you can define, that what is the shininess of the material. So these three things: diffuse light, ambient light, and the specular light, you must remember it. Okay, so diffuse light here in this example, this is the color of the light that is directly falling off on the object. Okay, so you have the light source, it is throwing this light on this object. Okay, and then usually there is some angle of reflection. Okay, so this is not reflection, this is the normal, which means that this is 90 degrees with this surface, and the light makes some angle. Why is this angle important? Because this angle of reflection will go into another object, and then we will see where will it go, and so on. So whether it's directly falling on the object or whether it's an angle, the light property will be different on this object. Okay, so we need to know the angle in general. Okay, but what we see in this light is diffuse light, which is from the light onto the object. Okay, next is the ambient light. So here, let's say the light comes from out, and then it has this surface, and then it reflects from here, then it reflects from here, then it goes here. So there are some reflections in the light. Okay, and because of these reflections, we can see this part as well. Okay, because if there was no reflection, we would only see this, but we are able to see this part, or we are able to see these parts because of the reflection of the light, and this is known as the ambient light. So this is not direct light. You can see we don't see the source of the light here. We don't know where is the light, but the light is falling from somewhere, and because of the reflection on different surfaces, we see those objects. So here you have different shades, and here you have different shades. The third one is the specular light, and as I discussed before, this is the shininess of the light. So you see this is like a shine. Okay, that is known as the specular light. Okay, so for different objects, this speculation, this specular source may be different and at different positions. Okay, now how do we use lights in OpenGL? Okay, so we have this OpenGL. We say that there is a function which is known as GL Light FV. Okay, so F means this is a float, and V means it is accepting what? An array. Okay, so we need to change some light, some property of the light. So this light FV takes three things. You see, first is the light source. So the light source can be light 0, light 1, up to light 7, any light source that we want to modify, and what type of property we want to modify, and what is the property value. Okay, so what are some of the properties of the lights? We already know one property is the diffuse light, the other one is the specular light, and third one is ambient light. And there is also the position of the light, which is a property. Okay, so in the example we see that if you want to change the position of the light, we will say GL light 0 and GL position, and then we will give the value, the property value. So what is the value? The value is an array, because we specify FV, so that should take an array, and that array here is defined as three values, X, Y, and Z, which is the position. Okay, and we give it GL float. It can be float, or GL float is the it means that this will take type float. So normally it can be GL float, it can be simply float. Okay, it's the same thing, but because we are using the GL library, so normally the float will have the name of GL float. It's the same thing as float. Okay, So GL float, light position, which is an array, and this is the position of the light in X, Y, Z. So we assign this position to this value of GL position. Okay, so now after this command, my light will be at position 1, 1, 1. Okay, this is one example of setting one property. We can have another property and another property. So the light 0 can have many properties, and we will call the same function for light 0 with each property. Okay, so remember the first one is the GL position, and we assign the position. Then the next one is we assign a specular color. Same light 0, same function, but we say GL specular, which means the color of the light. And here we say the color of the light is white. We remember 111 means white, and the last one is for alpha channel, which is pure like complete light, opaque. Okay, so in the previous example we had GL light 0 as GL position. In this example we have the same GL light 0 but GL specular light. So now we set the color of the light. Okay, then you see this is an example. Let's say I have this without lights. Okay, and if I enable light, I will have something like this white light. Okay, now this is very strange that everything is gone, but we will see how this can be changed. Okay, this is just an example. Okay, then after diffuse light is this example. Okay, if we want to set the color to be red color, so we can have this variable 1 0 0 0, so that is completely red color. Okay, if you want to set the ambient color, okay, and here also we have the same red color, but this time the name of the variable is ambient color. Okay, so we will change the GL ambient or ambient color. For diffuse it is GL diffuse. Okay, the function name and the light source is the same here and here. So we are always in the same GL light 0, but we are changing different properties. The first property we changed was the position. It was GL position. Second property is GL diffuse, which is the light color. Third property is the GL ambient. And GL ambient is also red because the light source is red. So we say that in the environment, the color is also red of the color of reflection in the environment. Okay. Now, the third thing is, you know, the material color, okay, which was the diffuse, the specular. Now, so we have the following options for the materials. It is called, no, this is the specular color, not, okay, sorry. The color is, yes, diffuse color, but the shininess is specular color. Okay, shininess is how much shine it will give and with which color. Okay, so if you want to set the material color, okay, that is about material. Remember, we are not talking about the light. Now we go to the material. Okay, what is the material on which the light is falling? Okay, for example, it can be a ball, it can be a square, it can be a house, whatever is the material. Okay, so material color, again, just like light color, we have the diffuse color, and material shininess is called the specular color of that material. So this is the same terminology like before, but for material we don't have ambience. Ambience is only for the light. Okay, so material color and material shininess. If you want to set the material color, we will have GL material FV. Front face or back face, this is the property. Okay, which face you want to have the material. Okay, we will see the example. Then which property and which value. Just like light property and light value, we have material property and material value. Okay, here we want to change the material color to red. Okay, so we will use GL front, GL diffuse, and material color. That will be for the material. Okay, so that was about light and the material. Two things we understand. In OpenGL, when you want to use, lighting, okay, just there are some chats. Okay, there was a question from Abdurrahman that if the light reflected from object to another, the light will be less shining. Yes, it will be less shining. Okay, so if there is a light from direct source, there will be shining. But if it is reflected on the other side of the object, there will be less shining. Okay, yes, that's thing. Okay, so I was talking about two things. One, we have light, and there are 8 types of lights, and for each light we can have the position of the light where we want it. We can have the color of the light, which is known as diffuse color. Then we have the ambience of the light, which is known as ambient color. And the third thing is the surface reflection, which is known as the specular color. Okay, so that is for light. On the other hand, we also have materials. Okay, so in one scene you may have one light, for example, but different materials. So there is material like paper, there is material like plastic, there is material like metal. Okay, and there is woods like door and windows. Okay, and there are many different types of materials like bricks, walls, etc. So these materials have different properties, and normally you specify these properties in the code, that what is this material, and then you set the properties for that material. So here we talk about now the absorption and reflection of the light. Okay, let's suppose that you are looking at a red car, and the sun emits a ray of white light. So the color of the car is red, and the color of the light from the sun, it is white. Okay, so the ray bounces off the car. Okay, the Asha, okay, Shah, it is the ray. It bounces off the car and goes into your eye. This is how we see anything. So your eye detects that the ray only contains red light, which is why you see a red car instead of a white car. Okay, so what does it mean? It is now the properties of our eye. Okay, why do we see only red light here? Okay, this is important thing to understand. How does reflection work? And you must understand this to understand the property of the light and how we can deal with light. Okay, so I will explain it in the next slide, that why our eye sees only red light. But we know that white light contains, here is the explanation. The white light contains all colors. You know this, that there are all possibilities. When you combine all those colors, you get the white color. Okay, so white color contains the red, orange, yellow, green, blue, indigo, violet, all those colors, they are contained in the white light. Okay, so when there is light on the red car, we see only red color. The question is, what happened to the green and blue color? Okay, because the green and blue light was absorbed by the surface and the red light was reflected. That is an important concept. Okay, so what is the reflection of light? When there is a light that falls on the surface, so some light will actually fall on the surface, reflected from the surface, and some will be absorbed by that surface or that material. Okay, so there are two things, reflection and absorption, and we will see that with the help of an example. So let's say you have the white ray of light. It is composed of 3 colors, for example, in this case, red, green, and blue. And there is the red car, red surface. So the red surface is red because it is reflecting the red. That's why we call it red. And it is absorbing the remaining colors. Okay, so that's an important concept in lights, that any surface which has a color, let's say any material, the color that you see for that material is because the material is reflecting that color and it is absorbing the remaining colors. So when we see something blue, it will be actually reflecting the blue color and it will be absorbing the remaining colors. Okay, now if we have, you see, a pure cyan light on the red color. What is cyan light? A cyan light is actually green and blue only. Okay, so when we combine green and blue, we get a cyan color. Okay, and if we have that light on the red car, so if the car was pure red, it would look black. That's very interesting thing. Remember this. Okay, if the car was red, then it would look black. Why? Because red surface means that it will reflect red light, but the light cyan, it does not have any red. Okay, so when this light, cyan light, it falls on this surface, it absorbs both the green and blue, and it does not reflect anything. So when no light is reflected from any object, that will appear black. Okay, so the rule in general is that when an object, it reflects all of its light, then that will be white. So white means the object is reflecting all of its light components, red, green, blue. If the object is reflecting only red light, it means that it is absorbing the green and blue, and so on. If you don't see, an object does not reflect any light, so it means that object will be black. Okay, so here is the example that this absorption and reflection of color will change the color of the object. Okay, so the property of the light will change the object itself, and that's what happened in this case. Here we have an object, okay, and when we throw a light on it, it becomes like this. Why? Because we did not define the material of this object. So if you don't define the material, it will actually, you see, have this behavior. Okay. Now there is another example. If you have this blue-green light on a magenta surface. What is magenta surface? Magenta is the color red plus blue. This is like magenta surface. Okay, and the color code is 101. So the light is green and blue. When it falls on this magenta surface, magenta will reflect what? Red plus blue. So magenta means it will reflect red plus blue. There is no red, so it cannot reflect red, but there is blue, so it will reflect only blue color, which means that this color, this object, which has magenta color, it will look like blue for us. That is very important. Okay, so this magenta color will become blue, and we will not know the actual color if the light is something like this. However, if the light is white, if it is white, then we will see the exact color. Okay, so what we learn is that depending upon the property of the color, the property of the light source, the color of the light source, this material will be in different color. Okay. Okay. Now, what are the steps to set light in OpenGL? We already discussed that first we will enable the light and the light source. So, for example, we have GL lighting and we have GL light 0. Okay, and then we will enable depth test to test the objects at the front and the object at the back of a scene. Okay, so what does that mean? It means that we will have 3D effect. So if we enable depth test, we will be able to see the objects in 3D. Then we set the light color, okay, with the GL diffuse. Here we will provide a value of which color we want as an array, 3 values, or maybe 4 values, red, green, blue, and also the alpha. Okay, then the ambient color, this is optional. So the light color is important. This is required. If you set a light and don't specify a color, you will see that the example in which I did not set the color, we had completely like a gray object. Okay, so optionally you can set the ambient color and then you can set the specular color. Okay, with these variables we need to remember them. Okay, then we set the material color. Okay, so GL material F is the function. For material color we have the GL front, GL diffuse we can have GL back, but normally we apply it to GL front, which is the side towards the light. Okay, so we first set the GL diffuse with some material color, then we have the specular color for that, and normally there is no ambient color. I don't think that this is optional, but it should not be there. We will try that if it is possible. We will see that. Okay, so there are some examples and we will see the example. We will develop it now. Here you see that we have this color setting. Okay, these are different colors. So red is 100, cyan is 0.8.8. So green and blue, they are combined to get cyan. Green is this, blue, yellow. When you combine the red and blue, this will become yellow. White is all of them are 1. Black, all of them are zeros. And shininess is just some value we specify shininess. Okay, so this is the value 50. Now we define those variables and do some color settings. Okay, You can use any color if you want for them to test how do things work, okay? And then the code says that we have GL material, we define the material, okay? That is the property of the material, okay? So GL front is GL diffuse is blue, which is here, this blue color, for example, yes? So we specify the blue color here. The position is 111, okay? And this one is extra, it should be X, Y, and Z. This one should not be there, because this is wrong. GL light 0, GL position, so we get it at position 111, and we specify that GL light 0, its color should be white, okay? And then we have a solid sphere. 1 is the radius, 30 and 30 are the number of segments, horizontal and vertical segments. So we specify a solid sphere. Okay, the light position is 111, and the color of the material is blue, and the color of the light is white. So we see this thing in OpenGL. Okay. Similarly, you see now that if we enable the ambient color, okay, so by enabling the ambient color to white, we see this thing. Okay, the same. We just added one line. So from here, it changes to here when we enable the ambient light. And finally, when we have the specular thing, you can see. Okay, so GL front, GL specular is white, and GL front, GL shininess is this thing. Okay, so it is white shininess, and this 50 is how small or big this is, and we will check this with the help of example. Okay, so let us run the last example. Okay, this example in Visual Studio. So I create a new project. Can we put ambient color and light color in same code? Yes, it will be in the same code. Yes, in this example, it is in the same code. Let's see. If you have any question, then you can ask me. Let me create a project. So we create a new project, empty project next, and it will be lights. Okay, we create that. We need some, code to start with. So normally we have, let's say the 2D transform code. Okay, wait, it's created. Wait, let me get the 2D transform code. Okay, and draw. This one is good. Okay, so we can take main from here. Okay, and in the lights, we have, just give me 1 minute. In the lights, we have the source file. There is no source file. We will add a source file. Okay, and we will call this as the lights. Okay, and that is a C++ file. We'll create the main, and we have the hash include glut.h. Okay, so glut is working fine, but we need to have the init and the draw function. Okay, so we will the init function. Okay, let's see the init function. What we have the init. Okay, so okay, this is the init function. Okay, I can copy the init function into the lights. Okay, here is the init function. Okay, now we have, I don't need to specify the, okay, I need to enable, the 3D, etc. Okay, so clear color, let me make it dark, so it will be black to see the lights effect. Okay, that's one thing. Secondly, we can have the perspective because we are using 3D. Okay, and then we need to enable the lighting, etc. Okay, so GL enable GL underscore. First, we need to enable the depth test. Okay, the depth underscore test, so that we have the 3D effect. Then we need to GL enable GL underscore lighting. Okay, which was the first step to enable lights. Then we have GL enable GL underscore light 0. Okay, but instead of putting everything in here, what I can do is I will define a new function for lighting. Okay, so what I can do here is that I will define a function enable lights. Okay, and I will define it above here, above init. So I will say void enable lights. Okay, and here I will do the lighting thing. Okay, so in the code, we started here. I defined all those lighting things. Okay, that's all my lights. Then we have the material, etc. So I will have this over here. Okay, here. Now GL flush, it's already there. We don't have a draw. Okay, so enable lights should be our draw function. Actually, we can call that this is our draw function, or maybe we can just let me see. In our draw function, we can have this. That might be our draw function. Okay, so my draw function, I will have this void draw. Okay, and in the draw, I will have just this solid sphere and draw it. Okay, so I define in my lighting, I have the light colors, then the material. Okay, light 0 position and light 0 color white. Okay, diffuse. Next, what we can have is that if I run this, what will happen? Well, I don't know. Let's see if it's working or not. Oh, sorry, I have not enabled this project. I need to enable this. So where is that? This is the slide. So I will set as start a project. Okay, we don't see anything. Okay, and there can be many reasons for that. We need to see the code that what is the problem. Okay, so it's mainly usually because of the position of the camera. Okay, so here the light position is 111. Okay, and what we have is that we have made perspective projection, but what is the camera position? The camera position is actually, okay, let's try one more thing first. Okay, just see in 2D. Okay, how does it work? So the clear color is this. We have specified this, but because we have not translated it, so we will not be able to see that. Okay, so it's better that we translate this first. GL translate F. Okay, this object, and we will translate it into, let's say, -3. Okay, that will put into the screen, this cube into the screen. Okay, still we don't see anything. Okay, why? Well, there can be many reasons once again. So I have done the translation and then I have solid sphere. Okay, if I don't enable any lights, for example, okay, let's see, I don't enable any lights and I don't enable this thing. Okay, and I have -20, 20 instead. Yeah, -20, 20 is fine. Let me make it 10. So that 20 is too much. Okay, and just before anything, this is 600 by 600, 200. Okay, this is single. Okay, I also not enabled actually. When I enable, you see here, depth test. Where was the depth test? Okay, when I enable the depth test, so here I should enable glut, depth test. But let's see. Okay. Okay, still we don't see anything. Well, that's strange. Let's see what else can be done. Okay, so GL translate, let me take it down by -2 and let me take it to -6, for example. Okay. Okay, still nothing. Okay, what's missing? We have not specified the color. So GL clear color and GL color, they both are the same. Okay, so normally we have the color, which is GL color, which can be white, for example. Okay, and that is GL color of GL color. Sorry, it's GL color 3F. Okay, so it's 3 things. Okay, GL color, let's run that. Still we don't see anything. Okay, now that's strange that we cannot see this, but we are run. In fact, we have already run of the time, so I will stop here and then we will continue inshallah from here. Any questions?